All right, all right, all right. Um, Xbox controller day. We are working on an Xbox controller. We need to get the PCB fucking finished so that we can, ask someone to print it for us and mail it to us because that is going to be a painful iteration process and getting it started as soon as possible is important. Before finishing the PCB design though, I kind of need to know where all the buttons go. So hardware design kind of like is coupled to that to some extent. This is where we are so far. We got this guy. I've printed him a few times. We've made some adjustments to the trigger placement and stuff, but I'm pretty happy with kind of where these guys line up. They feel okay in my hand. Button placement, pretty good. I might want to add some in the center just to have more, but that's okay. We don't have bumpers yet, which is really important. We need to add those. But like the big thing I want to get done today, the first thing I want to focus on is I want to add a capacitive button here. So the idea here is that I want to have gyro aiming on this thing. But also I want to keep the ability to press the D-pad with my right thumb. That's something I do quite often, which means that like I actually end up tilting the whole controller when I like put my thumb on this half, right? I kind of go like, whoa, like to like kind of reach over like this, right? And so for that to work, without fucking up aim, if we're using gyro aiming, we need some way to basically like automatically disable that thing. Either like a button we could press to intentionally turn it off. That's like definitely an option. But what would be nicer is if it just kind of happened automatically. And so what I'm thinking is if we have like a sensor here where my right pinky rests that says like turn on gyro if my pinky's been here, or it's like, has been here in the last n time, then when I rotate my hand, my pinky lifts off the button, everybody's happy, right? And then we can also use that for like ratcheting and stuff. So that's kind of what I want to focus on today is getting that thing flushed out. You can just like print a button there, out of 3D stuff that like 3D printed material that has like metal mixed into it, essentially, just like a little bunch of metal dust in there. And then it's like an electrically conducting surface, and it just needs to plug into the bottom of the PCB somehow. We just need to like print a thing that will like stay flush with this guy, and stay here. Like, maybe not flush, but maybe like a little indented is okay. I think I'd probably be okay with that. Actually, it's probably helpful. When I was like playing with the controller a little bit, it would help like lock my finger into place if it was like a little bit indented. But yeah, so that's the plan. Side question: would you call SQL a programming language? I don't know. Maybe. I mean, I don't really know that much. I haven't really done that much SQL, so there's that. But also, like, sure. I don't know, man. Okay. So let's start with PCB. We need to find somewhere to slot this button in, right? So we're gonna be on the back side of the PCB, and we're gonna be like somewhere around here, right? Like where the joystick module comes through. Right? So we kind of see if we take off maybe go like see-through mode. I was kind of thinking we do something like this. Like we have a button here, and he kind of like slides back. We need somewhere to like put the pads for this guy to connect to. Which if we look at like where we've wired everything so far, where we would naturally want to put this thing is like here somewhere, which doesn't really work. Well, maybe it does. Hold on. Let's look at the backside. Back layers. Okay, hold on. What am I looking at here? It's this side, my bad. So here, we've got a ton of like wires coming through this segment. So like mounting a thing here is not good, but in here there's some space, right? So that's not crazy. We've been kind of copying the Input Labs alpaca a little bit, which is what you get if you search like open source controller. You get this guy. And I thought that they just had the pad, like just a pad exposed there. I was looking at this guy. Open image in new tab. There we go. Oops. And I thought that they just kind of had like pads that they like stuck some like plastic on and trying to like slam it into it, and that makes like connection, and you have like electricity flowing through. But somebody pointed out in my YouTube comments the other day that they're actually putting like a little connector piece on here, which should make our lives a lot easier if we were to do the same thing. So let's look at like what they have, and then try to use that as inspo. Okay. So we open up this guy, we look at their parts list. And what are we looking for? I guess we probably should need to look at what this thing is tagged as. P2, is that here, connector. P1, P2. So that's this guy here, P2. So they've got this on LCSE, probably. Yo-Yo has a square wheel factory going. It's going great, dude. Pogo pins? Yeah, that sounds kind of right. What the fuck is a pogo pin? This is not the right thing, huh? Not the right thing. Certainly not. Was it P3? It says P2 there, but maybe the pins changed. So let's look at this one. That doesn't look like it either. Then what the fuck have I messed up here? Because the thing that was like in the YouTube comments, somebody linked me the part number. Let's see what they said. Let's see what they said. 707322. This one. So this is maybe we just have to like update the schematics or something. I guess that means that this resistor value I could have copied from the wrong thing as well. That seems quite likely. But okay, what is this thing? How does this thing even like solder on? I guess these 3 pins, like this bottom section here, gets soldered onto the board, and then you just slip your plastic through like the top half of this thing, and then probably as long as it's like inside that thing, it's kind of fine. Like, what the fuck is this thing? Okay, so this is why their pad looked like that. Why is there stuff over here? Because all the connections were from here. Right, this thing, like, it seems like pretty vertical over these 3 pins. So I don't know what this is for. Like, physically, I don't really see how the other side is, like, relevant at all. Unless it lays flat. Oh! Hold on. It could lie on this surface. So then you solder, like, so hard to, like, can I fucking get the picture? Right, like, it could be that you solder this, and this, and then it slides in sideways. And then that's why these 2 pins get grounded or something? That would line up? Can we look at their, like, assembly guide? So this is gonna be on, like, the front side. Between all the buttons. Do we have a picture of that thing? Front side, I guess. Assembly? This is like plastic, but can we can at least see this thing on here. Really low res though. Yeah, do they not have a picture of the thing I want? Doesn't look like it. Wait, maybe here? There we go. Aha. I see. I think that makes sense. I thought that it was like standing up vertically. This, and then just do these, then do you slot in here? I guess. Right? You probably poke into these little 3 holes here, and then these guys are like springy upwards and keep a hold on it. Would be my assumption. It pushes down flush, I think. I mean, wait, hold on. Maybe are we saying the same thing, but I'm just communicating poorly? Like, my understanding looking at this is that you like shove your thing in like here, like, you know, like this, and then like these gold plates will kind of like push out this way, and so that then like keep kind of pressure on the bottom edge from this view of like the 3 hole things you're sticking to the holes. I think that's my understanding. Okay, so like what the fuck is this thing called? This is just like a blade connector. Is that like a thing that I can easily buy from here? Blade. Blade type power connectors? I think you have a flat surface parallel to the plane surface that the surface that the pins spring up to touch. Parallel to the plane of the PCB. Interesting. Interesting. That's not my read on it. So you think they push in like in here? That would also make sense. That would also make sense. Let's look at like the part that they're pushing in. That's the bottom side? No, but like this is the bottom, but there's holes here. I just need to look at the picture or the part. So they 3D print this thing. So how the fuck? This looks like they're just like slamming into the top. Like there's no like little there's no like pins on that thing, right? They're just like shoving it in. This guy just like pokes through. Wait, where the fuck is it? The flat should push down all 3 spring contacts. Yeah, that actually makes sense now that you're saying it like that. I don't understand why I don't see it in the picture, but oh, it's this part here. It's poking through here. Okay, I see. Sure. Sure. So you just touch the things and you have like a little bit of jiggle because they're gonna like spring downwards. I see. I see. That makes sense. I see. So these are not that. I don't think. Dude, how the fuck? I mean, Blade does seem kind of right looking at that picture. Male blades? Maybe? That sounds kind of right. Oh, I see. They're just like inside some holes. I mean, I could just like literally copy paste their part. I just don't really. Yeah. I mean, maybe there's another search term that we're missing. What else does this thing say? It says shrapnel? What if we just browse this category on LCSC? They all look the same. Ish. So this is like shrapnel, blade shrapnel contact, 1.6 millimeters, spring contact. That sounds hype. Can we look up spring contact? Spring-loaded pogo pins and pressure. Oh, did you look for rectangular connectors spring-loaded? Rectangular connectors. Ah, good fucking call. There we go. Yeah, this is the shit, dude. Sick. And so then it doesn't really matter, probably. Probably we could just pick like almost anything. It just does not fucking matter. We just want to make like relatively good connection. So this thing's like 50 cents. And like what's our size here? 3 millimeters, 4 millimeters. How much space do we have on the PCB here? Like, how wide is this shit? I guess it's like it's probably like on the order of a centimeter. So we got tons of space. Tons of space. So that seems fine. 50 cents. What currency am I in? I gotta be careful to stay in Canadian currency. Yeah, there we go. Yeah, is 50 cents like about as good as we're gonna get? So I don't really care. Probably. Yeah. I mean, these ones are single pin. Yeah, this is about as good as we're gonna get, huh? Sure. Fuck it. I mean, I do. These ones exist. No, zero in stock. No pictures. No pictures. Yeah, fuck it. This is the guy. This is the one. The one. Uh, connector. This thing. Okay. Okay. So I guess we start by putting this thing in. Do we not have models? Are only step models, which blows. Which means that pad layout we're gonna have to add ourselves unless this thing already happens to exist in KiCad, which it might. We shouldn't ever assume that it doesn't. We should check. So probably we want like footprint, and we want to look for whatever the fuck this part's called. WM11 something 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 something. Yeah, no dice. But maybe it follows the like a standard pad type. We got 1.6 millimeter, 3.5 millimeter pitch and row spacing. I don't know if that like means anything. So like what does the bottom side look like? We got this on the top, this on the bottom. Is it just like exactly the same? I can't tell if the bottom side. Oh, also, what the fuck? We have 4. This thing has 6. So this is just like a different fucking. Hello? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This says 4 position. So is this datasheet just a lying piece of shit? Maybe it's the same fucking datasheet for both. Confusing. Okay, according to this 3D model though, It's the fucking same. Am I? Oh, 7/8 8/6/4. So maybe this is just all within this series, and then you're supposed to just know the rest. Okay. Where? So I guess it's just somewhere they tell us the width of the pins and the spacing between them. Presumably. Why don't I see them anywhere? 1.2 millimeter height, 1.6 millimeter pitch, but like how fat are they? Pitch and spacing between them. I don't know if it's like edge to edge or center to center though. Electrical requirements, mechanical requirements, durability, vibration, shock, tension, normal force, blah blah blah. Thermal shock, packaging, parts will be packaged, protects. Okay. Is this just not the fucking document I want? Oh, here we go. Product spec, test module setup. Yeah, this seems crazy to me. Am I crazy? I don't know if I'm just skimming too fast or if this thing just like if I have center to center width, sure, then how do I know how fat each pin is? Test sequences, solderability. Like, am I stupid? All force, shock, vibration, durability, temperature. Yeah, none of this looks like. There is normally a recommended footprint. Yeah, I'm a little confused. Maybe we look up. Can we like go to their website or something? Data sheets? Oh, pad spec. Here we go. Wait. Where the fuck were we? Oh, product spec and data sheet are two different things. I misread. That says product spec. Okay, data sheet. Data sheet drawing. Ah, here we go. So the data sheet is probably what we were looking at. How did I learn electronics? Actually, we weren't looking at this either. I don't know what the fuck I'm talking about. How did I learn PCB design? I don't know it, dude. We're just making it up as we go. All right, here we go. Packaging design drawing. So this is into the box, I guess, for like, this is like the tape for if you're feeding this into like a big machine that's gonna like stick this thing on the boards, I guess. But this is what we care about. Here we go, baby. This is the one. But it is nice having chat here because people in chat, I don't know why there are people watching me who know this much about electrical engineering, but there are people in here that are just like, oh, just do this. I'm like, oh, sick, cool. That saved me a couple iterations. Okay. So something that's unclear to me is like how hard we're supposed to push on these. Oh, here, nice. This is clear. So we can almost go, we can go all the way flat to the top surface. And it's okay with that. It's like designed to do that. Okay. Cool. Which means that we just have to like make a button that probably like, if we're gonna have some sort of error tolerance, that can just kind of sit like halfway. How far are these things off the surface? I guess this is all relative to some center position. This is 1.17, 1.4. This is... Oh, I see. You need to push it down to at least 1.6 for it to make connection. Then 1.4 is ideal, and 1.17 is minimum. So if we have, this is like 0.2 millimeter, I assume millimeters. I actually don't know what the unit of any of this is. I would assume millimeters, but I guess it doesn't necessarily say that anywhere. Oh yeah, here you go. Millimeters here. Sick. So as long as I can print something that will kind of make connection within 0.4 millimeters, that's a little rough, dude. 0.4 millimeters is, oh, I don't know how much I trust myself to be able to do that right. I guess that's fine. The printer itself, I think it prints in 0.2 millimeter layers, and it's a 0.4 millimeter nozzle. So probably fine. And then, but like we have to make sure that we might have like stacked errors, right? So if my 3D printer has errors on both sides of like where I'm placing the button into the case, as well as where I'm feeding the connector, we might get into a little bit of trouble. Maybe that's fine. I missed what this part is. Can you talk about it again? It's just like, so I'm trying to add a capacitive sensor for my pinky. I'm going to put my pinky on the bottom of the controller and have it rest there. And I just want some way for my controller to know that my pinky's in that position so that I can use that for like gyro ratcheting. So basically when I like lift my pinky off, I want the gyro to stop being engaged so that it like, if I rotate my thumb around the top of the controller to like press the D-pad, it doesn't like fuck up the aim when I'm rotating the controller to do that. Because that's like a thing I do sometimes. And so I am looking for some connector to like connect my conductive piece of plastic that I'm going to have on the surface of the board of the controller. I'm trying to like figure out how do I make that make contact with the PCB. And so that's, we're copying kind of the Input Labs Alpaca controller where they have some sort of like spring connector to do that. Okay, so what happens? What's the fallback plan if this doesn't work? Print again, right? If we like can't get within this accuracy, we're kind of fucked and we need to pick a different part. If there's another part with the same footprint and higher springs, yeah, a wire I guess as well. Yeah, the fallback there is that we just solder some wires in there and call it a day. Yeah, okay, that's fine. We can do that. Sure. So let's start here, and then if it comes to it, we do that. Yeah, that works. And then I guess also in the worst case, if there's like a little bit of wiggle, my finger resting on the button could kind of act as like a little bit of extra pressure as well to keep it in. So sure, fuck it. I guess that's fine. The fuck is a mating pad? Oh, I guess for if this is supposed to be a battery connector, the like thing on the other side. I see. Like the battery that you're pushing into this thing. But that's not what we're doing, so it's fine. So this is what we're looking at. All right, so I guess we need to add this to the schematic. And I guess we also need to make sure that we have 2 pins to work with still to measure capacitance. We didn't actually check that we had enough pins left over to do that. We have GPIO 13 here. Oof. That's not good. That's not good at all. It's possible that we could reuse another button for the same thing. Let's think for a second. So like, when we want to measure capacitance, the fast hardware iteration time is really one of the best things about owning a printer. Dude, it's crazy. I can't believe like how fast I can just like try stuff. It really lets me like play it fast and loose and have no idea what the fuck I'm doing. I think if I had to like machine these parts out of metal or something, it would be way crazy. Like, I would just not do it. It would be too hard. Technically, you only need 1 pin if you make your own oscillator. Yeah, I was kind of wondering about that. It did seem kind of reasonable that like if the if the capacitance measuring circuit that we have that we copied from them is like something along the lines of we have pin 16 is what we have, like, or sorry, just like one pin, I guess we'll call it out. We have this connected through a big ass resistor to, like, I assume to not drain too much power. Then this goes to like input, right? And then we kind of have like a capacitor here that is like our body, kind of hand wavy. So to measure the capacity, like when my finger makes contact with like this plate or whatever, we're hand waving away a lot of details. It means that if we toggle this guy like high, like we accumulate some charge on this thing, right? And then when we toggle this guy low, this guy doesn't see it until like all of this charge is gone, right? So that's why we have 2 pins to measure this when we copy their design. But like theoretically, I don't really see why you couldn't just return this back into an input and like pull the charge back off this thing, if that makes sense. Big resistors to get the frequency low enough to measure. Right. Otherwise, it would just be instant. So you need less current so that it takes more time for the capacitor to discharge or something. Sure. That makes sense. Not gonna lie, I'm graduating in computer science and I have no idea what the fuck is going on. Don't worry, I have no idea what the fuck is going on either. We're just kind of making it up as we go. Okay, so I guess there are a couple options here, right? One is that we could toggle between an input and an output on one of these other pins. Right? So we have a bunch of button inputs here that are essentially just like thing to ground. So if we put a big resistor just like on the edge of one of these buttons, I think that we would be able to then use it as an input to check if the button is pressed, then flip it to an output, and but then like the timings are going to change based off of that button, if the button's pressed or not. That seems not very easy. Charge for X amount of time and then see how charged it got, plug into the ADC. Yeah, true. We could do that. I wonder, like, okay, so what I was wondering though is if we just did like so if I said output, like set this like pin 1, we'll call it pin A. We set them as an output, right? And then just like go resistor to capacitor, right? Where this is like where my thumb touches, that is like just kind of like hanging, whatever, going through the earth or whatever, back. So we put this as an output and charge, and then switch this to an input with a pull down. Then see how long it takes for it to come back. You know what I mean? That seems like maybe possible. Maybe? Or we could do it the other way if that works a little better. I can't remember if it takes longer to charge or discharge. Probably charge. So maybe we switch it to we put output as ground and then switch it to an input with a pull up. Then read how much time it takes. We're using like a microsecond clock right now, but like maybe you could make this work with like the 12 megahertz clock. If this is just going to go faster because of these pull-ups that making it go so fast, you might be able to get away just toggling one pin. In which case we don't have to do anything tricky here. We could just use GPIO 13 and call it a day. That doesn't seem crazy to me. Check out how a keyboard matrix works. Yeah, I know that's an option, but I'd rather not. But yeah, we could do that, right? Even just using like a grid of like having 2 output lines does save us a lot of effort. Um. Okay, let's see if we can make this work with 1 pin. That seems kind of reasonable. That seems kind of reasonable. Like, maybe my idea here is fucking stupid, but there's only one way to find out. Only one way to find out. So, Pico. From scratch. Okay, so I guess the first thing that we want to do here is we want to change our time measurement strategy from using the microsecond timer to the 12 megahertz clock and see if that kind of helps us at all. So how the fuck do we do that? X oscillator. So when we like wait, how do we read this thing? There's like a counter in the 12 megahertz oscillator. And his value is like a UN32. This comes from 1C offset of this guy. So let's look at the RP2040 datasheet and see what kind of like how long we can measure with this thing. Status count. So this is an 8-bit counter. Oof. That's really short. Really short. What's this? Controls the startup delay. Yeah, that's not helpful. Dormant. Save power. Status. Yeah, not great. So wait, like if we have 1 over 12 million. Oh god damn it. Okay. Can we just open a Python console? 1 over 12 million times 255. That's the maximum amount of time we can measure, which is maybe enough. Is that's 20 microseconds, right? Right? Am I crazy for thinking that? 1 microsecond in seconds. That's 1 times 10 to the negative 6, right? 1, 2, 3, 4, 5, 6. Yeah. So maybe that we got enough time. For 1 pin, I'd probably try to make the sensing oscillator independent of the pi, and the pi just looks at the frequency of that. So you just have like you have like external hardware that's like let's pretend that I have no idea what the fuck we're talking about. So I guess you're saying like you have something that is going bloop 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 bloop. That's charging and discharging the capacitor, and then you just read somehow the time difference between when the oscillator goes down and when the capacitor is fully discharged, but that doesn't help you. You still need 2 pins. So maybe you're saying like you have something that automatically flips itself based off of the discharge rate, and then you use like the frequency counter to figure like then you see like you use the capacitor itself to trigger the flip. The capacitor could feed into a transistor or something, probably. right? Like if you had like what is the thing? You have like transistor and the output of the transistor, whatever, goes to capacitor and then the capacitor feeds back. And then this thing will just flip at like the rate that the capacitor allows. And then when I touch, that thing gets longer. And then we measure just like the output of this signal and like count between flips. Is that what you're saying? Sorry, I'm sure that like anything I'm saying sounds fucking stupid. Something RC oscillator. That does seem really familiar. Transistor or op amp or feedback through a network of resistors and capacitors. Do positive feedback on generate an oscillating sinusoidal voltage if it was analog. Is that basically what I said? God, that looks complicated. Said the guy who doesn't do any electronics. I feel like what I said is not that stupid. Wow. Fancy. What am I fucking looking at? This is... Oh, you're saying just shove a timer on there. That makes way more sense. I am the capacitor, so I'm this. I see. Sure. Sure, okay. That's an option, but that does mean that I need to buy a thing, right? Like I'd have to like put another chip on the board, which is fine. That's like an option. I'd like to see if my first idea works though. I feel like my initial idea of just like go back and forth, like make the pi the oscillator on one pin is not crazy. So here's the plan. Here's the plan. We use the X oscillator count thing. Does it count down or up? Which should allow us to get a more precise measurement. Down counter. So here, when we set this thing, we set this thing to 255. Then when we hit our interrupt, we read this. Okay. And then the time here is time taken is gonna be 255 minus GPI edge load time. Easy. And then I guess maybe we initialize this to 255 just in case. Okay. So we set the X oscillator here, fix that thing up, set this guy. Then we wait for this thing. I guess we kind of do it this way. This seems fine. If input is 0 break, Or even if we just go like, sure. Sure, we can do this for now. So we wait for the interrupt to fire, set GPIO edge load time, then we calculate this time taken as 255 minus GPIO edge load time. Okay. And this guy can even be like a U8 now. Probably. We'll bring back the timeout later. And I guess I go get the measuring cup and see this works. So like this is, we're still using 2 pins here. I just want to see if we have enough resolution to measure with the other oscillator. One sec, I'll be right back. Got it. We're so back. Okay. So this is... Okay. So if I run this thing now... He's mad because I can't set a U8 for this thing. It's fine. Okay. So if we picocom this thing and read it... Boom, 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 boom. Like, what is happening right now? So he's getting some numbers here. We're looking at like total time 25. I touch it. That's definitely changing. Weirdly not in a way that I like. Yeah, interesting. So here's like very consistent. Then I fuck up the capacitance of this thing, and then we start oscillating, it looks like. But sure. I mean, we have some signal. I'm actually curious. We ended up not using pull down or pull up because it didn't look like it was with when we added the pull down or pull up, we couldn't see reliable signal. Is that true here? Oh wait, hold on. Actually, hold on. Valid samples is always 20 here. Are some of these like just triggering immediately or some shit? I did want to look at that. If GPI edge load time is equal to 255, breakpoint. I just want to see if this is happening ever. Okay. So that is happening, which is probably not helping. So here we should probably actually be doing this here as well. And this is actually not edge low. This is a confusing name. GPIO transition time. Like, that's probably fucking a lot of stuff up. Okay. I mean, I guess it could theoretically be instant. So we're going like... So we initialize this thing as an output. Then we ask for interrupts on low and high transition. Then I guess, like, theoretically, maybe... Is this happening on, like, the first iteration of this thing? Is he getting stuck? No, he's chill here. It's as soon as I touch my finger down, he's getting unhappy. Right? He's getting... So he gets stuck, kind of saying like the transition time when I first put my finger on there is effectively immediate, which seems confusing to me. Seems confusing. Okay, let's change this to pole inline because I'm not really convinced that I trust this. Also, I guess what's our CPU clock running at? Our CPU clock might be like really fucking slow, which might be also not helping. So we'll call this like wait for GPIO transition. And this will return some timeout or something. And he is going to be like, you know, set the timer. I guess we have like pin here. And then we do like while true, we like read the input pin. Okay. If this is like expected, if val equals expected, return. That's it. That's all we have to do here. So this guy returns void, and then here, instead of waiting, we're going to disable the interrupt wave doing this. Okay. I guess. Yeah, we just comment this out, I guess. Then in the GPI handler, when the interrupt fires, let's just make sure this doesn't happen anymore. We'll do this. And then we'll say wait for GPIO transition on input pin. And we're looking for this guy to be set to high. And then here we read the count variable. Yeah. Sure, and then we do like something like this. And then we go like 255 minus end, and we say like time taken total time plus equals this. If end is equal to 255 breakpoint, that's kind of like a mistake, I guess, or unexpected, I guess, for it to be instant. Okay. Then that's kind of all of this stuff. And then I guess also or end is equal to 0, that's also unexpected. It's also unexpected. Okay. Then we do this same thing again, but we just do it with clear. And we're expecting to go to 0. Okay, which kind of is the same as all of this stuff. Okay. Does that kind of behave in a way that I think is reasonable? What's this about? This is at 685. We do need to dereference this guy. True. Okay, so the GPI handler is still running. I probably have to like full reset the chip. So I'm gonna unplug, replug. If I can, please, sir, stop moving around. Let me plug you in. God damn it! Why can't I get the fucking USB port thing in? There we go. All right. Okay, now that breakpoint's not hitting, I tap this thing to the cup. He's interestingly getting mad. Okay. So which one is it? P end. 0. Which I guess is fine. So that just means that we exceeded the time that we can measure, right? Which seems bad. That seems not good. So that's why I'm a little confused, is that feels like it shouldn't be a problem. I guess if we can just do like if end is equal to 0, we could just kind of reset the clock every time. But then our time will be less accurate every time we do that, which is a little confusing. Okay. That's maybe fine. So we'll just keep in mind that that can happen. Which doesn't seem right to me, but we'll come back to it. And now I'm not seeing any like reliable change when I press the button, which makes sense if the time is taking is like saturating, right? That does make sense if we're saturating our counter. So now the question is like why? Because before we were seeing something like on the order of like a few microseconds, which as far as I understand should be fine. Okay, I need to do this math again. I feel like I've missed something. 1 over 12 million. That's our period. Times 255 is each. So each we have. I mean, 0.123. So that's 1 millisecond. 100 microseconds, 20 microseconds, 2 microseconds. Wait, sorry, am I dumbass? 1 millisecond, 100 microseconds, 10 microseconds, 1 microsecond. Yeah, so we should have 20. I'm pretty sure that's right. And so just the idea that sometimes it takes more than 20 microseconds is a little surprising. Because that's not what we were measuring yesterday. So can we go back to reading the timer temporarily? Timer, read time US. US start, US end. If US end minus US start is greater than like 15 breakpoint, do these just like not agree with each other somehow? Touch, touch, touch. Yeah, nothing happening there. So tap this thing, touch, touch, touch. Yes, that's never happening, right? Which is confusing. So I guess we could just say if end equals 0 here and see what the difference between US end minus US start is. Because something is not lining up the way I want. You might want to watch a scope. Yeah, that's not crazy. Okay, so like we're just hitting this like immediately. So P end 0. P US end, P US start. So these are happening like in the same fucking. This is happening immediately? So how is this is weird, right? Oh, I'm a dumbass. We do have to wait for the GPO transition to wait for the GPO transition. Okay. Print end, PUS start. The fuck? Oh, maybe we should do it this way. That's probably a little bit. I mean, I guess that's probably a little safer. Okay, print end 0. PUS start, US end. How confusing. How confusing. Because according to my math, this should be like this should be the same. I guess okay, can we So something about one of these things I don't understand correctly. Right? That's the only answer that makes sense to me. That either like the watchdog timer must not be operating at the microsecond interval. It has to be that. It doesn't make sense otherwise. Are you trying to read while you're writing to the same pin? I think no matter what I'm doing with the pins, the clocks are not lining up with each other. That's kind of more what I'm upset about. Right? The fact that this guy is decrementing by 255, which should be on the order of 20 microseconds, and then we read this and 0 time has passed, means something's fucking wrong. It has to be something. It has to mean something's wrong. I don't know what. Let's just replace this for a second with wait 1 E9. We'll just wait for 1 second. And then breakpoint. Like, clearly I don't understand something. Okay, so info locals. Okay, so we have end minus start here. That's definitely not right if we waited for 1 second. Right? 11587. Can we Python, I guess? 11587 divided by 1e Python 3. Here. 11587 by 1e6. Yeah, so he thinks, the timer thinks 0.01 seconds have passed, and we think we've waited for 1 second. Right? So one of us is wrong. So I guess we have to figure out who's more correct. So can we just print every one of these? Hi. And then probably a number so we can see something changing. Var I equals 0. I plus equals 1. Alright, there we go. What's he pissed about? It's stood log debug, my bad. One Mississippi, 2 Mississippi, 3 Mississippi, 4 That's about right. That's about right. Stopwatch. So on 6, 7, 8, 9, 10. Right? So that's about right. I think. Uh, 9, 10. Yeah, I mean, that's about right. Though, I mean, obviously, like, my timing is a little off, but I think that we're on the order of a second, right? So that means that the timer, the microsecond timer here is like totally out to fucking lunch, right? This is about right. This thinks 11 milli. Actually, can we see what does this think as fast? It should be US end minus US start. Microseconds have passed. That's what we're trying to measure here. What's he pissed about now? Too few arguments. True. Little whiner, this guy. Yeah, so this is reliably saying 11 milliseconds have passed when we think it's been a second. So that means that our timer is probably just not initialized correctly at all, which explains actually like the accuracy problems from yesterday, like the numbers being so small. That lines up a little bit, I guess. Maybe. So it must be that like the timer, I think the timer is fed by the watchdog clock. And maybe we're just like not initializing that thing correctly. Watchdog gets clock ref here. Are we ever turn like do we have to turn the watchdog on? That sounds familiar. Okay. So watchdog reference clock, clock tick, is driven from clock ref. Ideally, clock ref will be configured to use the crystal oscillator. Oops, fuck. Okay? So that it provides an accurate reference clock. Reference clock is divided internally to generate a tick, nominally 1 microsecond. So use the watchdog tick. Tick is configured using the tick register. Okay. So we can enable tick generation, which is on by default. Number of clock tick cycles for the next tick. It's default 0. Count timer, which is read only. Okay. So tick is also distributed to timer and uses timer reference. SDK starts watchdog tick in clocks init by calling tick start. Okay. Watchdog counter is loaded by the load register. Current value can be seen in control time. Due to a logic error, watchdog counter is decremented twice per tick, which means the program needs to program double the intended count value. Okay. So I don't really want to enable the watchdog. I just want to use his timer and configure his timer. Like, surely he needs to know. We need to explain to him how fucking fast his input clock is, I would assume. Right, I would assume, which it sounds like would be configured with this, like, tick thing. But, like, I don't really see, unless we're supposed to configure the cycles value. Maybe? So can we look at the SDK and see if they do that? That would kind of make sense. And we're just not configuring that thing. He's probably configured to use the wrong guy. Watchdog. I can't spell. Not that it matters, but start tick. So this guy goes watchdog tick cycles LSB. Cycles is an input here. So who calls this guy? No one? Enable the watchdog. Oh, sure. Note if watchdog start tick value does not give a 1 megahertz clock to the watchdog system, then the delay parameter will not be in milliseconds. See the datasheet for more details. By default, the SDK assumes a 12 megahertz X oscillator and sets the watchdog start tick appropriately. Am I high in thinking that nobody fucking calls this? Unless it's hidden behind one of those like fucking like init macros. Like, what the fuck? And then watchdog tick enable bits. Oh, interesting. Wait, so this thing's just not in enable reset. So he's in reset on reset. Sure. That's not clear here. Then how does like the timer work then? Because the timer, like, what the fuck is going on? How is the timer giving us any values if the watchdog isn't on? Timer uses a 1 microsecond reference that is generated in the watchdog and derived from the reference clock, which itself is usually connected to the crystal oscillator. Yep. Okay. Which is here. So if it starts the watchdog and clocks in it. Where the fuck is that? Hold on. Runtime init clocks. He initializes the X oscillator. Sets the reference control clock. Clock sys, clock ADC, clock RDC, clock parry, start all ticks. Here we go. Ah. So he figures out what the reference clock is running at. And this is how many cycles it should take to do 1 megahertz. And he calls ticks start here. Using... I see. That's confusing. But he programs this tick value plus tick enable. Okay, that makes sense. So it's like, so he's just programming this in the tick register, cycles, he's writing this with how many cycles it takes, and then he's saying enable by setting this to 1. I don't really understand how enable reset is relevant here. It seems like they're just writing the 9th bit here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He's writing the 10th bit? Oh, sure, because this is 0 indexed. Yeah, so he's just writing a 1 into this thing to say start moving, and then programming this with the right number. Okay, so we just have to do that. We have to do that to get the microsecond clock to work correctly. And I guess in reality, we can choose to run this thing at whatever frequency we want. Okay. I guess that makes sense. So base. And then we need to add like a register for watchdog, probably tick. And he's got some fields. What's he got? He's got like count is 11 to 19. We got running is 10. We got enable is 9. And we got cycles is 0 to 8. Okay. which means that we can go back here and we can say watch tick is registers watchdog tick initialized with base plus 2C. And then in main, we can just start the watchdog tick probably here. So we're gonna write a few registers, and it's gonna be enable 1, and cycles is gonna be, you know, 12 megahertz over. It's just 12, right? If we're trying to run at 1 megahertz, and we're saying how many cycles to do one megahertz tick, it's 12 at 12 megahertz. That sounds right. One, two, three, four, five, six. So no. We're idiots. Is it because clock ref is not hooked up right? They said that this thing comes in from clock ref. Do we just never initialize that thing? Clocks. Clocks. Ref control? Okay, so we make him come from the X oscillator, which makes sense. Then after that, we say, count once every 12 cycles. Suspiciously close to 0.5 seconds. Oh, was I up by one? Is this not 5 seconds? Oh, yeah, it is 0.5 seconds. Oh, there was something about a double count in there, right? Right, they said that the... Due to a logic error, watchdog counter is decremented twice per tick. So we need to program double the intended count value. Yeah, okay. So we say 1 megahertz is 12 samples of a 12 megahertz clock. But RP 2040 E1 says that the watchdog double counts, so times 2. Right. What the fuck? How come that's having 0 effect? Because this is programmed. Oh, this is programmed. We have to do this after we set the clock ref. The fuck? How come if I double this, it doesn't double the time? Oh, it's the other way? Hold on. Oh, there we go. So maybe that error is for something else, and we just hadn't configured the clock correctly yet. Because that looks about right. Approximately. Okay. So now can we go back to using... Now we should have like a way more accurate microsecond counter. Right, so fuck using the X oscillator at all here. And we'll go back to using the microsecond counter here. So we'll say set the GPIO, wait for the transition, look for the end, and then total time plus equals US end minus US start. Chill. And this can just be a truncate, maybe? Seems fine. I guess we could do even like... Oh, it's fine. It's fine. Okay. Yeah. So now we're taking like 10 microseconds. I hold on and... It's kind of hard to tell. Hard to tell. Okay. So then we do this again on the other side. But again, this is on... We're just trying to clear this time. So we wait for this thing to go 0, and we log the time. Okay. So now we're looking at like 300 to like 400, back to 300. This is way more reliable now, which is nice. Okay, so this is with like the measuring cup 2 pins. Right, so this is finger on, finger off, finger off. Is this like... Why was it going to 400 before and now it's not? Now it's going like 290. Like 330. Like the difference is actually quite small. Why, also, why is it sometimes like struggling to keep up there? But sure, I wonder if we can also bisect like total time. Can we do like on time and off time? And then here do total time is equal to on time plus off time. And then log them both. I guess we kind of just want to log on time and off time here. Okay. So we're seeing like 130, 160 hold is like... Dude, it's so hard when the numbers are fluctuating so much. What if we just sample more? Oh, also, I guess like theoretically we should probably wait in between each toggle a little bit if we were trying to like let stuff accumulate. So we're looking at like 120, 150. Then it's like the off time is fluctuating. Oh, they're both fluctuating. Okay. I don't know, man. I guess maybe we could also sample for longer, which might help us see the difference a little bit more clearly. Weirdly, now I feel like on, off, on, off. Like, why am I seeing no difference? Click. Release. Oh, yeah, we are. Click. Release. Click. Release. Okay. Sure. I mean, I don't really feel like this is really gaining much. Sure. We're seeing something. We're seeing something. And I guess I wanted to see if we also see something. So if I enable pull down on the input pin now, like does it dominate the time still now that we have like a more accurate measurement? Oh, it doesn't, right, of course. So here we get stuck because he always reads 0, despite the fact that the other pin is high, because the pull down is stronger than the resistor between the two. Right, so that's why that didn't work. So we can't do this anymore. But the experiment that I was really trying to work towards was, can we flip one pin between an input and an output and have the same behavior work? Right? So if I'm like, in this setup, I unplug this green wire, which is GPIO 19, and I just have white to orange. And I touch orange to this guy, and I click here, right? This is kind of the experiment we're on. So here we should be able to charge the capacitor by holding the pin high for some amount of time. Then we should be able to count how long it takes to discharge it after. So I think what I want to do is like, let's think for a second. I'm thinking. I wonder if we could just leave it as an input all the time and enable the pull up. That might not be crazy. Right, so we could do pad control is okay, we have this, and this is the output pin, right? We have pad control read initial value and I guess we want to actually weirdly initialize this guy as an input, right? And say enable the pull up. Then we get the value of this guy, and we say that this is the pull up on. Pull up off is going to be a modification of this guy with pull up enable 0. Right? Maybe? But then something needs to drive this to ground, I assume. So it's almost like we want combine pull up enable 0 and pull down enable 1. Maybe? That seems more reasonable. Right? So we're like pull up on. I guess this is like pull up, pull down. Right? Then we write to the pad control maybe 1 mega ohm to ground, charge with output high or pull up, go high Z, and how long it takes to discharge to the 1 meg. Ooh, that does seem more reasonable, right? Okay, let's think about this. So it depends, I guess that depends on what the internal pull up is. What am I fucking doing? Pull. Like, does it say like the strength of these anywhere? Like RP 2040 pull up. Pull up resistance, page 634. Yeah, so we're in like the 50 kilo ohms range. I don't think it's tightly controlled. Sure. But I'm more wondering like order of magnitude. Like are we with like the 1 mega ohm resistor, are we eating like most of the voltage drop? Like if we put output, is it like close to 3 or is it close to like 1? You know, was kind of like the order of magnitude I was looking for, which looks like so because like if it was eating like half the voltage, I think that would change things a little bit. But I think that's not the case. Okay, so I am changing the circuit from essentially I'm going 1 mega ohm plus like 50k to here with a capacitor here. And you're saying I could do 1 mega ohm to ground. Capacitor has to be here, I think. And then here we charge with this, then cut and read back and see how long it takes it to turn to ground. I'm kind of okay with that. That doesn't seem crazy. Does not seem crazy. Yeah, fuck it. That seems fine. So I'm connected. So I just need to move the resistor to ground, right? I just have to go like take this resistor who's connected to the white line and connect the other end of him to ground, I guess. Which I think just works if I just take this white wire and I plug it into the right spot here. I think that's grounded. I think we can check that by taking my scope and just seeing if I touch this end of the resistor and the ground pin. Which is, I guess, over here somewhere. Just kind of. He's given me. I guess we can also measure the difference over the resistor, which is 3 volts. Yep. Okay, that makes sense. Isn't tension time for low listen spec? I don't fucking know, man. I don't know what we're talking about. You're assuming some competence that I don't have. Okay, so in this scheme, we want to say floating. Yes. So it's like this, which means that we can actually just change this to pull up enable 0. Okay. So we turn on the pull up, pull up, pad control, right, pull up. Nice. Then we wait until the output pin is 1. We need to rename this. It's fine. It's fine. So we wait for this thing got to transition to 1. And I guess we could see how long that takes. It's not crazy. Then we let them float and add that to the off time. And maybe we give a little wait time between just for shits and giggles. Oh shit. This modifies, I see. So you do pull up modify, except we need to do like const var const floating equals block. This is a bad API, but it's fine. So we say like floating var floating is pull up, and then we do floating modify with pull up enable 0. Really, on these value guys, this should not be the API, but it's fine. It's fine. All right. So on time, off time are pretty stable right now. And if I put my finger on here, nothing's happening. But also we are not waiting for it to transition to 0 here, which is pretty important. So that might be related. Okay, so now that is taking some time. And if I put my finger on versus off, on, off, on, off, on, off, I'm seeing absolutely no difference. Absolutely nothing. Which is surprising to me. I would have thought that this works. I would have thought. I'm going to connect the scope here just to make sure that, like, this transition is happening. So I need, you know, some wire here. I think you have the measuring cup on the wrong side of the resistor. Yeah, I might. Now that you say that, that seems quite likely. Because I have it on the ground side. Yeah, you're right. You do seem correct. Okay, let's try that again, actually, then. What language is this? We're using Zig. Alright. Oh, yeah, there we go, baby. Look at that shit. Look at that. On, off, on, off. Wait, and this is actually, like, more reliable. That's, like, way fucking clearer. Wait, we're fucking chilling. We're fucking chilling. One pin, baby, let's go. One pin. One pin to rule them all. One pin to bind them. In the darkness, find them. Well, one to find them. One pin, something, something in the darkness. Bind them. You know that movie from like 20 years ago? Is that right? 25 years ago? My guess is 2001. 2001 is my guess. Oh, dude, 25 years ago is a long time. Okay, so that's actually sick. So that means we can just jump back to the schematic, and we're chilling with this guy being single pin. So what is this circuit that we made? It's this. So we have 1 mega ohm tier to ground, capacitor. So this goes to P1, or like the pad, and then also to GPIO. So it should be, let's add a section here for, can I just like copy paste this because I don't remember what this thing is. We'll call this, I don't know, capacitive, what do we call this thing? It's for like ratcheting. That movie where the two gay guys go up a mountain, Love Brokeback Mountain. Yeah, that movie. I guess that movie was more the third one. The first one that was kind of more like 7 guys hanging out. Okay. The fuck is this called? I guess like grip sensor is kind of like an okay name for it. That's kind of like its purpose. And so this guy needs like a resistor. R. This guy. Do I have to specify like his value somehow in here? Probably, right? Like in here, can I write like, I think if there's a value field in here. Do I write like 1M? That seems kind of reasonable. Uh, so this is to ground, is what we said. Whoop. Then top end goes to our pad, which we said we were gonna buy. Did I lose it? Did I close that window? Why do I just have like fucking like 8 calculators open? Yeah, I guess we fucking closed the window of the part, but good thing I wrote it down. So we want to go to this guy. Fuck me. Wait, I have to copy from within Vim. Paste, 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 paste. Hello? Why? Go to the end, copy, paste. Holy fuck. Okay. So we need to add this guy to our parts list. I guess we didn't write down the, oh, we did write down the DigiKey side too. Nice. Okay, so let's add this guy to our parts list, I guess. So do we call it custom? Yeah, we did. Okay, so we add a thing, this guy, and he's got one output, right? So it's just like draw me a fucking box. However the fuck you do that. Boom. Boom. And then here it's just like passive. Pin number 1. And this guy is just like, is this how you're supposed to do these? I can't remember. Can we look at like this guy in the symbol editor or something? It's the other way. No, wait, yeah, that looks right. Looks right. It's just this guy's small. Can we make him bigger? Boom. Center that bitch. Boom. And then do we give him a name or we just kind of... Sure. Connector's usually J. Oh, am I supposed to change this to J then? Like this? Yeah, because U's are usually like chips and shit, right? I guess they used P in the other schematic that we were looking at. What's P for? Like, is P like pad or something? This seems like the type of shit the idiot would know. What do the letters R, J, P, C, and U mean on schematics? Resistor, jumper, power. I mean, he didn't lie about the other ones, so I'm not like, you know, entirely against that. J does seem... I have seen J for connectors before, and it does kind of feel like a connector. Maybe they just use P for pad, and that's not like standard. That wouldn't surprise me. Would not surprise me. Okay, so then we add this guy. What the fuck is this thing called? This thing. Boom. And then both of this kind of connects like this, and then this goes to here. We add a label, grip. Flip that shit. H? No, I thought it was H for flip. Oh, X. X for flip. X for flip. That's what I always say. So delete this not connected bitch. And then grip goes here, right? That's it. Seems reasonable. Right? Right? Sure. Simple. Then this guy needs a footprint added to him, which doesn't exist yet. So we need to go to the footprint editor and make him. Oops, I had it and I lost it. This guy. Footprint editor. Custom? No. Library? What the fuck did we call our shit in here? Or do we just not have a custom library for this thing? We must for the, like, PS5 connector? We have custom. Why when I search custom? Okay. That's cool. I don't give a fuck. I don't know, man. I misspelled. Okay, you don't have to, like, make me sound like a fucking stupid dumb idiot. um... Cut some. Okay. So, where was the footprint here? So we want 1.6 millimeters center to center. Which means that his center is going to be 0.8 millimeters off to the right and left. And then this is 1.7 from to the bottom. 1.7 plus 0.4. 2.1. 2.1. 2.1. I don't remember how to do any of this though. I've already forgot. Surely somewhere draw a rectangle? No. Add pad. 1, 2, 3, 4. Okay. And this is 0.8 and 2.1. Is that what we said? And then the pad size is am I high? What's the width? Wait, am I fucking stupid? Do they 0.7 here. 0.7 and 0.8. Okay. So negative 0.8, negative 2.1, 0.7, 0.8. And then this is going to be negative 0.8, 2.1, 0.7, 0.8. Then this is negative 0.8, negative 2.1, 0.7, 0.8. Does that look right? I think that's the right shape. So that's likely that we got that correct. Then I guess we draw a box around this guy, which is, I don't know what, like, this is. This outer box doesn't fucking matter, I guess. It's like this inner box. But then this is kind of, do we not have, like, his profile? Is this the outer profile here? I'll call them all pin 1? Yeah, true. True, they are all pin 1. I agree. Here, this is the profile of the guy, right? So it's 5 by 3.2. So we draw that kind of like this. So negative 2.5, 2.5. But it's 5 width, right? No, 3.2 width. Oh, 3.25. I'm a dumbass. Okay. Negative 1.5. 6? 6? No. No. It's only on X that it's wrong? So shift it left by 1 millimeter? Yeah. Okay. So that matches up here. This 5 millimeters is this 5 millimeters. This 3.2 millimeters is this 3.2 millimeters. And then they're like, you could add some space around it if you really fucking wanted. Sure. Eder box is front courtyard? What does that mean? Front courtyard. I'm sure that you mean something, I just don't know what. Oh shit, wait, why is this is the 6-pin one down here? Okay. Yeah, so this was right. Oh, you said I put no, this is silkscreen, I think. Right, it's yellow. I think no, this it would be red if I made this. I think it's when I click this box, it automatically puts it on there. Like if I click this and then click this box and draw it. Oh no, it does. I don't know how the fuck it ended up being correct, but it was. Maybe it's this is connected by default, and then if I click pad, it automatically selects red. I don't know, but it's not. Okay, sure. So this should work, I think. So here we can put the footprint here of that guy that we just made. And then I guess we could add him a 3D model as well. It's not out of the question. Okay. So now I guess we go to the PCB and we say update from schematic. Errors 1. Change, cannot add R1, no footprint assigned. True. True. Can I resistor? Is it just like a thing? Oh my god, how do I know? I guess we have to pick a resistor, huh? We gotta add a fucking resistor to the board! Hello, DigiKey? Sir? Through holes used to hand solder? Yeah, true. And I guess I have a 1 megahertz resistor sitting on my desk that I just did here. So I guess we could just look for resistor through hole. And then here it probably doesn't, like, it doesn't matter that much. Right? Like, something like this probably lines up. What's like the footprint for just like a normal fucking resistor? Wasn't a step file priority? Yeah, there was. Footprint of normal color coded resistor. Like, is this like a stupid thing to search? I guess we can just look at this up on DigiKey and see what they say. Because this is like essentially what I got. 2W axial. Size 5 millimeters by 16 millimeters. That feels really big. But it looks like they have like axial, which does make sense. 2W is pretty big. Yeah, this doesn't look like the right size. I guess I could just measure this thing with my fucking tape measure. Look for 1/4 W resistors. So like something like this. His size 2.3 by 6 millimeters. That's hand wavy, the right size for the thing I'm looking at on my desk. Yeah, 6 millimeters is about the right length. Okay, cool. So 2.3. So it's like this. 2.5 by 6.3 millimeters is like a hole that kind of fits the right thing. right? What's the difference between this one and the one underneath it? Oh, just like how far apart I want the pads to be? Sure. So I'm like, these are like, they're all the fucking same, but I can kind of like space out the pads more or less if I want, because the fucking, I can bend the wires however much I want. So probably like this, right? So we're leaving 10 millimeters between holes. This is 7 millimeters between holes. Yeah, sure. Let's just do this. Okay. So now he's happy. He knows how to do that. But we have all this shit to place now. So this thing needs to connect to the grip sensor. Grip sensor is going to live on the back. I don't know why. So we only have the resistor? What about this guy? Where's our J1 here? Ah, here we go. Oh, and then we have some resistors that are some capacitors that I haven't placed yet. But this is kind of the important part I'm trying to focus on right now. So this guy, we want him on the back side. I think I press F on this guy. Then we can go to the back assembly view. Didn't really do what I want. I thought that if I flip this guy, shouldn't his pins turn blue and shit? There we go. That's what I wanted. I'm aware resistors. Oh, the W is watts. I'm aware that this is not about size but power. Yeah, I agree. It's like power. You need a bigger thing to dissipate more power, so it's not really a size thing, but it's approximately. You could think of it as a size thing, almost. Yeah, I agree. Says the guy who knows nothing. Okay. So we want this little J1 bad boy. Oh my god, we want him kind of like over underneath the right stick. So like if we kind of grab this line and kind of keep him close. What was the fucking move this thing hotkey again? Drag, D for drag. Yeah, if we kind of like bring him over here like this, that gives us a little bit more wiggle room. Why the fuck? Okay, right? Like we kind of did this. That gives us room to kind of put this in the center. Kind of far from as much as we can, which should make it easy to make contact with this with a button. Right? Seems reasonable? Honestly, we could go bigger if we're worried about this thing being too small. Like looking at it in the PCB, I'm like, it does feel, it's fine. Like what is the size of this thing again? I forget. Yeah. Was it here? Yeah, 5 millimeters by 3 millimeters. I guess that should have thrown up a red flag. That is quite small. But we can always just be bigger and make contact. Then if we get the fat one, it would be like 5 millimeters by 5 millimeters, which is still small. But I guess it's fine. Are you intending to get a stencil and use solder paste? Solder paste? Dude, what a word. I can't fucking read it. Solder paste. Yeah. I think I want to try baking it in my toaster. So there's a lot of components that I could solder by hand. I'm kind of trying to keep that open, mostly. But for these like really small components, I either have to ask the PCB manufacturer to put them on for me, or I have to like bake them in my toaster or something. It would be really funny to bake it in my toaster. Because like for this and the IMUs, they're both too small. But also like the pin layout is like fine, I guess. I don't know. Yeah. I don't know. It would be funny at the very least. And I think that's a big win. So we can try it, and if we don't like it, we can kind of we can iterate for V2 or pay them more money. If you're gonna hand solder, make the pads longer. Well, for these ones, I was going to place like for this, I was probably gonna place in the oven. But you are right that I could just make the pads bigger, and that makes it easier to solder. That's a pretty good point. Are these two close together? That looks really close, but I guess I won't think about it. I don't like that there. Yeah, fuck it. Wait, where the fuck did that J go? Hello? Where'd he go? What the fuck? How did I lose him? Undo, undo. Did I just hit delete on him or something by mistake? When I was trying to do this? I mean, I'm not against making the pads bigger just to make my life easier. Even if I decide to do it in the toaster, just having bigger pads helps anyways because it means that I can like see placement a little better. So just change this to like 1. Even bigger, probably. Like, we go all the way up to, like, 2, right? Right, we could kind of, like, do this. Like, fuck it. Why not? Boom. Then this guy, we say update from footprint. All right. Fuck it. Have you seen a board go through solder reflow? It's neat to watch. You don't have to be super exact. Surface tension will pull the parts into alignment. Yeah, that seems super cool. I've like looked at it a little bit, not enough to know if I can do it, but it is kind of neat that the board is like designed to kind of pull stuff where it's got to go. Okay, so we connect all of these lines together. Wrong side. You know, we just kind of do like a boom, 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 boom. I guess we might as well just do it all. Fuck it. Boom, boom. And then here, we can just go straight to here. Easy. Why is I feel like the lines were snapping before. It's because I'm drawing lines instead of fucking connections like a dumbass. I'll also click this button. That makes way more fucking sense. There we go. So now he's correctly running around here. So we should be like kind of going like, whoop, whoop, whoop. Easy. Any reason why you don't just have one huge pad? I don't know. I don't know. It does seem like you could just have like one big metal chunk there. And that doesn't seem insane. I guess like probably for alignment purposes. Right? Like if like the idea that you want to know exactly where this motherfucker is. And in fact, by adding these like 1mm wiggle here, it's actually harder for me to tell now. Right now we have to account for the fact that when I place it, I could slide it around vertically and that would be a problem. But we can just design like the connector to this thing to like be tall enough that that wouldn't matter. But I guess if you just had one big pad, you would have trouble like knowing where you place the thing, would be my guess, but I don't know. right? You're assuming that I could tell you good design rules, and I can't. Because I don't know what the fuck I'm doing. Okay, can we like add the step to this thing? 3D models. Weirdly, with mass manufacturing, you pay for copper removed, not left on. I think that actually makes a lot of sense, right? Because like my understanding of like the way that these things are manufactured, which could be wrong, is like you have like this like hunk of this sheet of copper, and you just like kind of like cut it out, and then to like make traces, you're like kind of like having a machine like go and cut around some section, right? And so like it makes sense that like you start with sheet, you pay for the whole sheet of copper whether or not you're using it all, and then like you're paying for time on the machine, right? So the more cuts that the guy has to do, the more things are being done, more money. I think that's my understanding. But again, I don't know what the fuck I'm talking about. All right, step file. Where we were trying to add the 3D model to this guy, right? So we are trying to go like maybe here, click this guy, 3D models, add, and then here we need to download that step from DigiKey and make sure it lines up. What the fuck? Models? Dude, I fucking hate how if you resize your browser a little bit, it thinks you're on a phone. This is so stupid. I want it to know I'm on a desktop. Like, just... fuck. Alright, so we got... this guy. We probably extract this into work. Here, PCB. Then we extract this as like... the fuck? Oh, do I just extract to this folder and then this thing has the right name already? Maybe. Maybe. Yeah, here. So we just have to make sure to add that to our Git. So that we don't lose, because I will forget. I will forget. So like we add this, and then do we have to configure paths? I kind of want just like a local relative path, but maybe that's not going to work. Hello? How come clicking on the little folder button just like nukes my computer? Home, streamer, work, Xbox controller model. Is that where we put this thing? Better? PCB? Step. Hype. Okay. I mean, that looks about right, but his offset is, dude, these icons are so stupid. They're using like they're using some like default like plus minus buttons, but the minus is turned into an X. And so like it just doesn't know what the fuck is going on. That's so funny. Oh fuck. Okay, so this model, delete. This one needs to be like negative 1.5, negative 1.2, and then 2.1, 2. I think it's 1.2 here. Sure. They do both with manufacturing boards. Remove to make traces, then plating for vias and through holes in board edge if you want what. That makes sense. Makes sense. Okay. So at the very least, he fits. And then we look at the future. Wow! Wow, what the fuck is going on? Oh, it's because like the center. Weird. Okay, so I guess we should also place this resistor, huh? Might as well do that. So this guy needs to just like connect to ground anywhere where there's space, right? So we can just kind of like slap this over here or some shit. It doesn't really matter. It would be nice if we weren't crossing other lines though. So we could actually do it over here on the red side. Oh, but he's this only blue. We can come like through here maybe. Right, that's not crazy. Can put it on either side of the board. The resistor, sure, but the connection to this has to be on this side unless I want to go through a via, which I could do. I just didn't want to think about it. I mean, that fits well. Sure. Um, can we do that like fill all zones shit? There. And then view 3D viewer. There he is, baby. Do I feel like the resistor fits better on the front of the back? I think back is better because otherwise he's going to conflict with this button. So he's going to go on the other side. Not that like it matters that much, but we should like this. View 3D viewer. Yeah, that's better. And then even this could cause problems, to be honest, if I don't clip it like perfectly, because there's going to be like a button that sits on top of this thing. So I'd actually prefer to not have it so close there. Can we like bring him down? Does this cause problems if he's like over here? He'll be like over some vias, but that's probably okay. I think. Should be. Just to give myself a little bit more space. Yeah, that's better. Now he's gonna... This is fine too. Because this is on this side. He's not gonna run into that chip. Yeah, fuck it. Which means what's left is for us to figure out how to connect this thing. So we need to figure out the distance that this guy, our like connector needs to travel from here. So we're gonna put the button like here, right? This is where our like capacitive button is going, and we need to like attach this to this. And I think we wrote down all of the values yesterday somewhere, or like maybe the day before. Here. So we already did this. So we put the origin of this guy kind of on the surface of the controller, which is here. So that's probably this. Then this is the pad location. This is probably XY wrong. Z is like the bottom of the PCB. So this is going to be like, we just have to change this now to match whatever the fuck we placed here, right? So, I guess we check in here. We look at his location, and then every location is offset by 100. So this is 26 x26, that lines up, and then y12. We're really close here. It's like negative 12.1, and this is 26.0. And then the z value just needs to be adjusted to be offset from the board surface. So the board surface is 0.3 millimeters in world space, whatever. Doesn't really matter. We just need to decrease this, I think. Which way is up in Z? Up is towards the front. Yeah, so we need to do pad height is from the data sheet, probably. Right here, they tell us that we want to be at 1.4, right? So, 1.4 millimeters. Okay, so that means that I guess we'll import, so this is gonna be like 3D printed out of like a different material, right? And we want him to kind of like sit on the surface of this guy with a stick that's gonna come out and come touch over here somewhere, right? So I guess we need to design like something that's gonna clamp on to like the back surface of this guy to hold him in place. So I think that we can assume the PCB will hold him vertically, right? Once he's making connection with this guy, he won't be able to move up and down. So probably if we just take like a cylinder and put it around him and then cut a hole, he won't be able to fall out. And then we just need to make sure that the cylinder is a little wide. We need something that's like, if this is the surface of the controller, right? Like we're gonna have like a hole here for this guy. I think we want like cylinder kind of like this, right? So that he's kind of gonna come flush like this. This little hook here and here will stop him from falling out. And then this cylinder going around will stop him from moving. I guess like this hole will keep him from moving, so it's kind of fine that way. And then we'll cut a hole in the cylinder for like the stick to come out, and then that will just that will point it in the like exact right direction. That seems reasonable to me. Fuck it, sure. Which seems like a CAD task to me. Seems like a CAD task. Okay, let's copy paste this stuff to today's to do. And then I guess probably, where do we want to like assemble everything together? I guess like keeping this surface owned by Blender makes sense because we want to kind of match the surface shape to the shape of the outside of the hole. Kind of like the top surface, but the bottom surface we need like a flat section here so that we can like sit flush against it, right? Yes. So I guess we'll kind of like make a cylinder for the top of our button that goes all the way up, right? So I think that what I think makes sense is we kind of in our FreeCAD thing will be like he'll kind of come all the way through, right? So he's gonna look kind of like this, right? And then we can just do an intersection of like this and this to limit him. Or we could just have this cylinder come all the way up and do an intersection of whatever button we make here and like the outside mesh that we sculpt. And then that will automatically turn into this shape. Yes. In which case, the origin of our object matching up with where we want to place it on the PCB, I think makes sense. So maybe we put the origin here. And then everything else just kind of lines up. Sure. That seems reasonable. Yeah, let's do that. Let's do that. So which one of these like fucking 80 windows is FreeCAD? Let's just close KiCad. I don't think we need this open anymore. Close. Oh my god. Close this. Close. 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 Close that. Okay. I guess we didn't even have FreeCAD open. But we make a new guy, and it is called grip button or something. Fuck it, I don't know, man. We start with a sketch. And I guess this is going, we'll call Z up to keep our coordinate spaces like somewhat similar. XY plane here. So we start with, I guess, the stick, right? So we're going to have some surface that is at maybe we should be origin in the center of the PCB. The surface makes sense. Surface makes sense. Okay, so we'll say that he needs to be 1.4 millimeters above the surface, and we need to be maybe like 7 by 7 millimeters, or yeah, 7 by 7 millimeters or something. It doesn't really fucking matter, right? So we'll just draw like a 7 by 7 millimeter square in the center. So like approximately here. Constraint. Oops. I didn't even know that was a constraint I could add. Fuck off. Let me in. Let me edit the sketch. Please, God, please. Okay. So this is 7. Can we move that label so it looks like less fucking stupid, please? Thank you. This is also 7. Okay. And then we want this guy to be centered, right? So can we just say like this point, this point, this point, symmetrical, delete redundant constraints, and then this point, this point, this line. Symmetrical, okay. Oopsies, I fucked up. Delete redundant constraints. Boom, boom. He is fully constrained. Let's go. Okay, so this guy, we need to be offset by 1.4 millimeters in Z. Right, so he's going to be a little bit above. Wait, it was 1.4, right? Yeah, here. Okay, and then I guess we need to. We want to like extrude this guy, kind of. We want to. There was something that you can do to like move him along some other surface. Maybe it was pipe. Sweep a selected sketch along a path or to other profiles. I'd probably do a loft for the diagonal. Which one's loft? Additive loft. Let's see. What is like CAD loft? Can we just look at like a picture? Oh, sure. So this says like I want to go from one shape to another shape, just fucking like get there. Can anyone help me with Photoshop spelled with an F or AI to make small modif? Can't make it work, please. Dude, what are we doing? What are we doing? Why is this how you get information? This is crazy. That's crazy. Yeah, so you're saying I go like loft and I need to pick a profile? Maybe I don't understand. FreeCAD additive loft. Make the second profile first. Yeah, that makes sense. What is the profile supposed to look like? So C is the final destination. What the fuck is B here? By making a transition between two or more sketches. Oh, B is just like another surface. So I just make two spots and then loft between them. Hey, Sprook, you want some recipes? I don't know how much salt I should add. Dude. I'm such like a. I know you're joking, obviously, but uh, dude, my cooking is so fucked. It's just like I have like one spice. It's just salt. I only ever use salt. Anything else is too advanced for me. And I just like I just have like the one box, and I'm just like, every time, and then I put too much every time by mistake, and then I'm like, salt. That's about like the extent of what I'm capable of. Capable of is the wrong word. I guess care for is the right answer. Right? Obviously, I have this like twisted idea that anybody can be like top 10% in the world at anything. Right? So like I'm not like I think that I have like the capacity to cook well. I just don't care. Chef's kiss. Mwah, yeah. I just eat boiled white fish because I was too lazy to cook. Yeah, I found like for a while I had the exact same burrito for every meal for every day for like years. And then one day I just ate one and puked. I was like, okay, I guess we're not doing this anymore. Then I switched to making quesadillas with all the same ingredients, and that kind of solved that situation for a little bit. But then I started like hating eating for some reason. Body no like eat anymore. Yeah. But there's something so funny about just like, yummy. Okay, so we need to figure out, I guess, we're moving over by. This is 14 millimeters minus 1.4. So I guess we just make a new sketch where this is going to connect to the back of the button. So I guess we know this might be the wrong thing to be referencing here, right? We kind of want to know where this is. So I guess that's kind of like the same thing, just with the thickness of the surface. So we take this like point, we take this 14 and then subtract 1.5. So this would be like 12.5 here. So I guess we start with a sketch. We'll figure it out. We'll figure it out. So we need 23 millimeters minus 26 millimeters. So we're like X is 3 millimeters off. We need 12 millimeters minus 22 millimeters ish. So we're like Y is 10 millimeters off. And then the Z is, we said 12.5 minus 0. Plus 0.5 millimeters ish for this. Okay, so this is like 13 millimeters minus the 0.5 for the height. Or what was it? 1.5? Oh, but we don't even need to do this because the origin's here. Sick. Okay. So we'll do this. We'll put him here. So I guess we make a sketch. We make a new sketch, new body even, maybe. Maybe same body. Same body, one sketch. He's gonna be on the XY plane at 310. Okay? So we're gonna take a circle and we're gonna put him like 3 millimeters here and then 10 millimeters here. Hand wavy, that should be approximately right. We don't have to be super accurate because we're going to use this as like the way to cut the button hole on the other side. Then our radius here, we want this to be relatively large, probably. Right, so we want this to be like probably around 1 centimeter large for my fingy. circle at origin. I think I don't want to do that. I think. I could be wrong. It might not work for like the way that the loft works, but this feels. We'll see. We'll see if this works. This is how it makes sense to me. Okay, because this is not. This is not the loft. This is the. This is the cylinder part of the object. So this thing has to go. What do you say? 13 millimeters up, which looks about right. So I want to pad this guy up. Sick. That's exactly what I want. Then we need to create a connection to the bottom of this thing that will make it to this pad. You're saying you'd prefer the sketch, you'd prefer to edit the sketch attachment? I don't really know if it matters. In my head, it doesn't seem as nice to do it that way. But I do get what you're saying. You could do it that way. I just don't know if it's like better or worse. Okay, so now we need to create a sketch in this body that's like, I want him to be like attached to this guy, right? That's kind of what I want. It's more relevant with pipe. Yeah. I see. I could see that. Where you also specify the path. Okay, so we want. Why is there a chamfer here? Can I just. What the fuck? How did this end up? Get the fuck out of here. Okay, so if I want to just like go to this, which I don't think I do, I think I want to like make a section on the bottom of this that like turns into this guy, right? So if we do like, I like make a new sketch here. This might be stupid, but I feel like this is what I want. Where I draw like, I don't know, a circle on the bottom of this guy, hand wavy, that's like kind of centered in him. Which, is that like a thing I can do? What's the like bring a projected edge into this thing? This guy? Right, so I can like. Now, you're saying. Then like, do I guess I can create lines from like the outside of this, the outside of this, and the outside of this, the outside of this. Is that how I fucking center this shit? Is that stupid? This feels stupid. Oh, wait. Can I just link to the center? Probably can, huh? These guys are these are the same point, which is this. Nice. And then I set the radius of this guy to be like, I don't know, 8. Wait, but we said that we want the inside of the button to be fatter, actually. So that's not this is not where the guy's gonna end. We actually need to. I need this to become like fatter so that he can like rest on the bottom of the controller. You know what I mean? Like, so like the inside surface, he needs like somewhere to sit on. Which means that it's actually better to start with a fatter button here, I think. Yes, this first sketch was wrong. So this guy should be fat as fuck, not this guy. This guy. We need to make this guy fatter, so we'll make him be like 12 millimeters, and then we'll pat him the other way. So he'll come down, like by negative 2 millimeters down or something. Yeah. Sure, that makes sense. Then we create a sketch on his top surface. Yes. This is making sense now. You're saying you would have done something different, but I think that's okay. I think there's many ways to bake a cake. Or something. What's the fucking saying? Okay. So now this guy, I want this point and this point to be the same fucking point. Please, God. Okay, and then I want the radius of this guy to be like 10 millimeters. Or the diameter, sorry. Then I can pad this out. And I can do that. Perfect. Perfect. That's what I'm looking for, baby. Okay. Now we can make our stick to here, right? So we draw on the bottom of this, kind of where we want this thing to end up. And I guess we could just do like another 7mm by 7mm square, right? Like, fuck it. Just keep things simple. Oopsies. Hello. God, please let me edit my sketch. Thank you. So this is, 7. This is 7. Then we project the external geometry and we keep, god damn it, why do I keep fucking double clicking escape? Then we make it so that our center, which doesn't exist right now, I guess we can do like this distance. I guess we do a construction line maybe. We say like this to this. Oh my god. Stop leaving the sketch. You can make two. You can make them symmetric to the center point. Oh yeah, nice. Nice. So these guys are symmetric to this. I thought the symmetry had to be around a line. Hype. Okay, so now these are my 2 segments of the loft, and can I just like loft between them? Is that what I can do now? Right, can I just go like additive loft? Oh, I want a profile. So I can't just pick the 2 ends. You can pick the 2 ends. In select feature, select the sketch piece of the paste profile, pick OK. Oh, I see. Oh, wait, okay. I think I get it. So there's add section. This. Oh, come the fuck on. That's beautiful. Beautiful. Why the fuck is there a chamfer in here again? What the fuck is going on? I never added chamfer. Oh, is that the additive loft? What am I looking at here? So here's the button. Where the fuck did my loft go? Am I fucking brain dead? Get the fuck out of here. Delete. Okay. So how come I click this, additive loft, go to here. Okay, there we go. Okay, so that's my button? Maybe. We might need to dial back the height of this section a little bit. That's possible, but let's kind of export this and put it in Blender and just kind of see what that looks like. Wow. Is this thing twisting? That's probably fine. Okay. Import. STL. Grip button. This thing's mega big, so we scale it down to be the right unit. Okay. Then it looks like our coordinate spaces were a little bit inverted. That's true. So rotate in Z or rotate in X by 180. And then looks like we wanted a rotate in Z by 90. Okay. And then does this end up where we want it to go? Oops, we're backwards because we were inverted, huh? Fuck. I guess we just change maybe the first sketch location. If we change... delete this, move him down over here. Wait, where the fuck was that? Oh, I see. We move him down like this. And then we do it this way. Hello? Hello, why can't I fucking click? There we go. 3. Side note? How the, like, am I crazy for thinking that this stuff isn't fully constrained? Like, maybe I'm missing something where, did everything else update correctly? Like, couldn't that 3mm distance flip me to either side of that axis? Maybe it, like, is smart enough to know that. Can I recalculate? So, like, how is that thing fully constrained if there are 2 valid locations? Okay, so the button... I think that inverted correctly. Everything's fine. Like, my dumbass is like, isn't that just not fully constrained then? Import. STL. So this guy again is too fucking big. Okay, and then rotate him around X by 180, then rotate him around Z by 90, I think it was. And then we try to place him. Okay. So that's a good sign. Everything seems like it's lining up the way we expected it to. I guess his Z position, we have to make sure it lines up with the surface of the PCB, right? That's what we kind of shot for. First of all, let's get this fucking ugly annotation out of the way. So here we want the Z height to be the same as the surface of the PCB. So view, we kind of copy this Z value to this guy. And I guess we don't have, like, we haven't, like, tied the 2 PCBs together yet, but we could do, like, at least, like, a measurement here to be like, is this around 1.4 millimeters? We don't have to be perfect, but if we're like, what am I measuring? I guess we put the cursor here. Is that how this works? No? How do I... how do I fucking measure that height? Whatever. We'll eyeball it. That looks about right. I guess we could put the STL. We could also put the step file of the button in there and just, like, place it to make sure that it works. File, import. This guy. Yeah, right. So that is just kind of working, but we can, let's kind of put it in Blenderland just to have everything in one spot. File, import, STL. This guy, he's too big. As always, we scale him down. Right, so now we kind of just, which side are we on? This side? So we offset this guy's Z value. Interesting. Oh, I see. He's rotate Z, rotate X this way. And then now that surface looks kind of right, and we just have to find the right spot for him. So it's like under the joystick somewhere. Wow, that actually landed almost perfectly. We could probably move him just ever so slightly this way. Right, so assuming that this is where he's going to end up on the PCB, which I guess we actually know exactly where this guy's going to be. Can we do object, set origins, center, center of mass, and then we just edit the X and Y positions to match what they are in the piece in KiCad. Yeah. Yeah. We can export the PC from KiCad. True, but we haven't done that yet, so we'll just kind of hack it. 26, 12.1. So, negative 0.0121. There we go. So that's where he's supposed to land ish. This button looks like he's kind of sticking on the surface. Okay, maybe he's a little large, but that's okay. He's not colliding with any of the pins. And then over here, he is making it through here. And then we'll just like crop this guy to be the right size. So I think we can do... We'll have to get a little bit more clever with this, but like this cutter is going to need to be a little bit larger, but for the purposes of this test, we can do something like get rid of the hole punch that's coming through here. Actually, I guess we should keep that in, and we could just scale this down to be approximately the right size. So he needs to be like a little bit larger than this. Okay. So now there should be a hole for this to come through, and then what's going on? We kind of had a button here before, which I don't really want. Where'd he go? This guy. No. Is it? This is what I don't want. So this is, we called it ratchet. Yeah, that's ratchet. Get that shit out of there. Delete. Okay. So now we have our guy coming through, and we just need to intersect this thing to be like totally inside the PCB. So we do like what the fuck? Add modifier geometry nodes. New. There we go. Where the fuck am I? Where's the fucking nodes? Here we go. So we intersect this. With V3. Intersect, boom, boom. It doesn't like that. Relative. Boom, baby! And then we need to adjust. We need to make this actually this needs to come like farther down or something, right? So this stop section is like colliding with the inside, right? So what we actually have to do is we have to bring that whole stopper section up, right? And then, kind of bring a platform for it into the controller, right? And then also, we need to like bind this guy, so we need to make like a holder for him. So we need to add like a cylinder in here. The way I've done this before is I add a second body here that's like the outside. All of the pieces that we want to like add to the controller. But my head hurts. I think we've made a lot of progress today, and so I think I'm ready to take a break. What did we do? We rejigged our capacitive button sensing code to work with single pin. We found a pin on the PCB to add that thing. We routed it, and we found a connector to connect to, a little spring-loaded guy. We figured out where we want to place that on the PCB, and we got an approximation of a capacitive button that would hook up to that thing. That's like pretty big fucking progress. So happy with that. I need a break. My head hurts. So, thanks for watching, guys. If you like what you saw, we stream most days, 12:30 Pacific time, for 3-4 hours ish. For clearance, I usually use the offset field in shape monitor. Okay, good info. Thank you. Appreciate all the help, by the way. So it is 3:30 now. We usually start around 3 hours ago. This VOD will probably not go to YouTube, but a lot of the VODs do. It really depends on if I think it's something that's, will get clicks, is titleable, thumbnailable. So generally, coding, feature development ends up on YouTube, but the rest ends up in Patreon, YouTube member, or Twitch VODs, whichever are available, but you have to pay to get access to them. If you want that access, that's great. If you would like to support the stream, please consider getting access to those. It's a way for me to make some money. This content will end when I run out of money. So, every dollar I make extends the lifetime of this stream by some amount. Otherwise, I think that's it. Thanks for listening to the blog. Let's find someone to raid.